Hi. Comparative planetology is the study of planets by comparing them to each other to see what kind of similarities and differences we have. So then ultimately trying to see what is the origin of the similarities and the differences both in planets. And so I want to speak about the giant outer planets first, which we have the two gas giant planets, Jupiter and Saturn, and the two ice giant planets, Uranus and Neptune. And for scale, they're shown with the other planets, the rocky, Earth-like or terrestrial planets here. And in this table, I have listed a number of properties about each one of those planets along with the Earth for comparison. And the Earth is not, for many of these properties, it's pretty much the same as the other terrestrial planets. So the focus here is on the gas giant planets and these properties. So first of all, in terms of Earth masses, Jupiter is by far the largest mass. The mass is the total amount of material, and we determine the mass by if something is orbiting, we can measure how fast it's orbiting and how far its distance is from the planet, and through Kepler's laws we can determine the mass of the object. So all of these have had their mass determined because they have moons, and Jupiter is 318 times the mass of Earth, Saturn 95 times the mass of Earth, Uranus and Neptune 15 and 17 times the mass of Earth respectively. Now, the density is very different between these outer planets, giant planets, and the Earth. The density is the mass divided by the volume, and here compared with water equaling 1, which means 1 gram per centimeter cubed is the density of water. So rock has a density of something like more like 4 or 5, and gas is less than 1, much less than 1, and ice and water is about 1. So the density of Saturn is even less than water, 0.7, and so even less than water, very fluffy kind of planet. Jupiter and Uranus have about the same density, 1.3, so more dense than water, but nothing like the density of rock. Neptune is not too off at 1.6, but Earth, the density is 5.5, a much denser planet, which means there's a lot more mass in a much smaller space. And so even though these look like small objects, and they are compared to these, there's still a lot of mass compacted there. Moons, the outer planets have many more moons. Jupiter has about 67. Some of these are unconfirmed, but they're confident that these have been discovered, but these are the most optimistic figures that I have. It's 67 for Jupiter, 62 for Saturn, 27 for Uranus, 14 for Neptune, and 1 for the Earth. Rings, well, the planet Saturn obviously is known for its rings, but all 4 of the giant planets have rings of some sort. The rings of Jupiter are dark, carbon-like, smoke-sized particles orbiting around, very difficult to detect unless you have the sun lighting the back side of them, and so they can light up from behind. These were not discovered until the missions to Jupiter, Voyager mission discovered them, looked back and saw the rings there. And Saturn's rings are made of ice and rock up to the size of a house and down to the size of a snowflake or smaller. Uranus has does have rings, and there are some bright arcs in Uranus's rings corresponding to regions of extra density of ice in those areas of the rings. Neptune has also rings that go around, and for these planets, their rings are very narrow, not like Saturn's, and somewhat dark, but also bright because they have where they contain bright ices. They're bright. The core of each of these, we have a large rock core, probably in all 4 of these giant planets. Something about the size or bigger, especially in the case of Jupiter, than the Earth. Something very large that is like one of these rocky planets. Maybe up to 5 times the mass of the Earth for Jupiter, and somewhat less for the other planets. The mantle, the interior part between the core and the outer layers, we have metallic hydrogen in Jupiter and Saturn, very thick amounts. Jupiter and Saturn are made mostly of hydrogen and helium, and it forms in this metallic form under high pressure. Water ices, these are the ice giants. Water ice makes up much of their constitution. Other kinds of ices include ammonia and methane ice. And in the Earth, of course, we have silicates, which are rock, and we have metals. In the core of the Earth, it's an iron core. So the structure of these inner planets is much different than the giant outer ones. Atmosphere, hydrogen and helium is the main constituent for Jupiter and Saturn, and Uranus and Neptune. But Uranus and Neptune also have significant amounts of methane, CH4, which makes their appearance blue in color. And on Earth, we have nitrogen, oxygen, carbon dioxide, and water vapor. Mostly nitrogen and some oxygen, smaller amounts of carbon dioxide and water vapor, and maybe trace elements